Welcome to Shaping Science, a collection of videos from the voices that are shaping science today. I'm Charlene Lancaster from The Scientists, and today we are joined by Dr. Sridhar Iyengar, founder and chief strategy and technology officer at Elemental Machines. In this episode, we'll explore how artificial intelligence can transform laboratory operations by enabling more proactive, data driven decision making. So, without any further ado, let's get into the science. Hi, Shri. Thanks for joining us today. It's great to meet you.
Yeah, likewise. Thank you very much for having me.
To start, historically, why is it so difficult for researchers to look back and pinpoint exactly what went wrong when a key instrument suddenly malfunctions or goes out of calibration?
Yeah, so one of the great difficulties, and I used to be a bench scientist in a previous life. One of the big difficulties is you're not actually recording everything all the time. And so, you do your research, you do your experiment, and you look down, you look at the results, and you say, well, that doesn't make sense. Maybe something went wrong. And you kind of go back and then you realize that some of the things that you should have been recording weren't recorded. So good examples would be when you run something over the weekend and then let's say you're incubating cells over a weekend, and you look at your cells on Monday and you say, well, they didn't grow the way that they usually grow. I wonder what went wrong. If you had looked back and you're able to detect things like, oh, somebody else came in and opened the door over the weekend or didn't close it right or something like that, then you kind of get an insight into the root cause. But very often, those kinds of things are not recorded all the time. Another example is something gets sent out for calibration or something, and it's being used in the lab, and it's a shared piece of equipment, and then without thinking about it you use it, and then you realize maybe the set point wasn't right or maybe the configuration wasn't right. So those things are not often captured because nobody's pulling all that data 24/7, because it's not really an easy thing to do. So wouldn't it be great if you had somebody following you around all the time, taking notes on everything you're doing so you can look back? That'd be great. But that's one of the big problems in research that I've struggled with, is finding the root cause and going back in time and getting some insight in there. But because you're not recording everything or measuring everything all the time, you have an incomplete data set that you can look back on.
And that leads into my next question. So, every scientist has experienced a failed experiment. How does centralized operational data change the way teams investigate failures and identify root causes?
Right. So again, building on what we just talked about, yes, we've all experienced failures, or we could say unexpected results, and the problem is uh, the data that you want sometimes isn't available. And if you had a central repository, then you can go search. And what I mean by that is, again, if I use the same example as before, assume a colleague went and used a piece of equipment. Wouldn't it be great if you could go somewhere and find out what that person's settings were or what experiment they ran? A great example would be contamination. And we've all had this experience where you see somebody using a piece of equipment, you're like, oh my God, I don't want to use it after them because they always leave a mess or they always screw it up. Wouldn't it be great to know who the last three or four people were that used that piece of equipment and when they used it? Because oftentimes things like cross contamination can happen if it's not properly cleaned. And if somebody that normally doesn't use a piece of equipment, let's say from the next lab or upstairs, comes and uses it, they may not leave it in the same state. So, but having a place where you can go and say, well, who used this the last time and what experiment did they do? You get kind of an idea of how it was used. Would it Was it potentially contaminated, or et cetera? And then also you can go talk to that person and say, hey, what did you do and what did you find? So, data is very siloed, especially in many research, uh, many research groups. So having it all centralized and, more importantly, easily queryable, that's the main thing. Can you have that data easily queryable and findable?
Great. And artificial intelligence is a massive talking point right now. But what does it look like in a practical day to day laboratory setting?
Yeah, I think this is something we get asked a lot, and we see a lot around as well. That Everybody's on this AI hype. The world had its Chat GPT moment a couple of years ago, and everyone went crazy for it. And it's an amazing technology, but at the root of it, it really is just another layer of abstraction. If you think about Google search, when that came out a couple of decades ago, that was mind blowing. Well, ChatGPT and these large language models, LLMs, are just yet another layer of interpretation on top of that. And everyone is accustomed to, instead of searching for results or answers on the web, everyone is now accustomed to asking a question and forming questions of what's out there. And so, in a practical day-to-day lab setting, things like that can be implemented as in, ask questions of your data. So you got a large data sets, you can chat with your data. So that's one thing that we're seeing, kind of really taking shape. The other side of this is that I look at that as kind of a passive use. You have a data set, you have an AI interface, you can ask questions, you can get an answer as opposed to search results. On the other side, and I think this is the more exciting part, is folks who have traditionally not been software engineers or software developers can now build their own tools. Now that's huge, because now you don't have to rely on somebody else. You don't have to go to your data science team and say, hey, can you uh, make me a little widget to analyze this and this, or you don't have to rely on really complex Microsoft Excel scripts and things like that. You can literally use Claude. We use Claude Code. I use it all the time, but to develop internal tools. But imagine a scientist going, you know what? I want to make a little widget or a little tool that does X, Y, and Z, and you literally ask the AI agent to develop that tool just for your own use. So that we see as kind of unshackling and freeing people from the constraints of the software that they're using in front of them. That's a huge opportunity.
Going into your solution, how does your new AI platform warn a laboratory manager that a piece of equipment is at risk of failing before it actually shuts down?
Sure. I think everyone is accustomed to the concept of having a health score. I think from a personal standpoint, it started with Fitbit, 15, 20 years ago, when they said, hey, we can you can measure your own body's progress and performance and all that. And so there's that concept has always stuck with me. That can we determine the health of a piece of equipment? And obviously, there's loads of folks out there who are looking at this whole field of predictive maintenance, and especially in the manufacturing world, factories employ predictive maintenance technologies all the time. But what we look at in the laboratory, it's a little bit of a different beast, because whilst predictive maintenance, which is telling somebody that, hey, you should do preventative maintenance now and not wait for it to break unexpectedly, whilst you can do that in a manufacturing and factory setting, I won't say easily, but it's a lot more straightforward, because they execute the same procedure, the same process over and over and over again. That's why factories exist. But laboratory is very different. Every single day you're doing something different. So all of a sudden, what the approach that worked in a factory setting or manufacturing setting, where you're running the same process, doesn't really scale. This doesn't work, and certainly doesn't scale um, to a laboratory where every single day you're doing something different. So that was a challenge that we took on, and we looked at that and we said, how do you figure out what's going on with a piece of equipment when it's being used intermittently, when it's being used by different people, and it's being used to run different protocols. And so we had various ideas over the years, but of course, when AI tools and infrastructure became accessible and cloud based, like it did in the last couple of years, we jumped all over it. So we have built an entire platform, and that we called it Elemental Alloy. And the idea with alloy is, any alloy is strong because it takes multiple types of materials together to make an alloy. Same way, Elemental Alloy is our AI agentic platform, and then we have built individual agents on top. And one of those is we call the analytical equipment analyzer. And what that does is it pulls data from various sources, user manuals, your CMMS, your break fix data, pulls utilization data from the devices that we have, and it pulls log files, and you name it. Whatever information the customer has, it's augmented by the data that we collect from our devices. Put it all together, and over time, we can see how that machine has been used and what the risk of failure might be, because our system learns from the break fix data, the operational data, the data that's in the CMMS, and kind of cross references that with patterns it finds in the log files and the usage patterns, and the risk of failure, eventually goes up, or very rarely it goes down, because you obviously, wear and tear on it. But the whole idea is AI is imminently suited for that kind of analysis. It's pulling disparate data together, finding hidden patterns, and surfacing those patterns and risk factors that a human being really doesn't have time, or even the bandwidth to kind of figure out what's going on.
In regulated or good manufacturing practice environments, the stakes for equipment failure are incredibly high. How does automated monitoring provide the traceable proof that protects both compliance and scientific integrity?
Sure. So if you look at any GXP environment, the cost of a failure is very high, not only monetarily but also reputation wise. If you're a CDMO or something like that, then you really don't want to go through that sort of that experience. And so, again, if we go back to the very first thing we talked about, the ability to monitor and record everything gives you that traceable history, where you can do two things. One, when something goes wrong or unexpected, you can go back and find the root cause very quickly. So that's one. And in many cases, when you find the root cause, you can take corrective action in your process, or in that work product. We've seen examples of where something was out of range, reagent wasn't stored correctly, so before going on to the next step of production, they would then look at that reagent, do some analysis, and then say, okay, it may have been stored out of range, but it's still viable. Or to say, you know what, if we increase the concentration by 15%, it'll counter the loss of activity. And you can take corrective actions like that. But you can only do that if you can point back to something and say, here's the rationale behind that. And you can do that easily, I quote easily, if you measured everything and recorded everything. And that's one of the philosophies that we want to bring to the market and to our customers is, hey, let's make it super easy to record everything, because it's an insurance policy. In case something goes wrong, you can go back and take a look at it and either do corrective action or very quickly fix your process so it doesn't happen again.
Looking ahead, how does the scientific process change when researchers can completely rely on their equipment and stop playing detective when things go wrong?
Again, when I was a scientist a few decades ago, um, I remember I spent about 2 or 3 months trying to track down why one of my experiments wasn't working, and um, it turned out that the department had switched the brand of dishwasher detergent that they used to clean the glassware, and the new brand left a little bit more residue that got redissolved when I was using it in a beaker. Again, it's not equipment, it but being able to look at the purchasing history, um, that's what allowed me to say, oh, wait a minute, you purchased something else. But just like that, if you are able to do planned maintenance, or you're able to surface changes in the process proactively, then you're not spending time second guessing your results. And more importantly, this is far more important and far more relevant these days, because virtually every life science company not only has the wet lab and the wet lab scientists who are working on that, they also have a dry lab, which I've heard called. It's basically folks on the AI side, the data science side, the analytical side, and many, I won't say all, but certainly not all, but many of those folks were just trained as data scientists, and they have a bioinformatics background, but they may not have a wet lab background. So here's what happens when you got somebody sitting over on the dry lab side. They just trust the data that's going into their systems. On the wet lab side, you have people watching the technique, and so anyone who's done wet lab work, you know that technique matters. And if you're the same person doing the experiment and getting the data in the wet lab and sitting down and analyzing it, when you see an anomaly in the data, you can think and say, oh, wait a minute, I know that was due to a technique issue, or that was due to I use machine number 2 as opposed to machine number 3, and that's what the difference was. That data, that insight, intuition, doesn't readily get to the dry lab side if they're disconnected. And so when more and more companies are having that split, it is far more imperative that whatever data does go to the dry lab side for analysis is really reliable and has all the metadata associated with it. You could the data that's collected could be, oh, this came from machine 2 versus 3. Well, guess what? If that data metadata is transferred over, even better, then they have that traceability. So that's really what it is. It's traceability and connecting the physical work that you do to the digital analysis. So physical to digital divide, that divide is far more important today than it ever was.
Great. And how does automation improve both the day to day experience of researchers and the overall efficiency and performance of laboratory operations?
Today, you can think of automation not just as repetitive actions, but as customized actions, customizable actions. And a lot of that is driven by the AI intelligence that's behind it. It can, quote, it can think and react accordingly. So what we're seeing is a host of, I'll take liquid handlers. You have a host of liquid handlers that can perform far more complex tasks through, and they can do if then statements. If this happens, then do this. It's conditional programming, which, you go back 10, 15 years and you didn't have that ability across the board. And now you do. And a lot of that is being able to interpret the results and then figure out the next thing that the system needs to do. So that's all enabled through AI based intelligence platforms.
Amazing. Thank you so much, Shreed. It was a pleasure talking with you.
Awesome. Thank you so much.
To learn more about how artificial intelligence helps laboratories improve operational reliability, efficiency, and performance, please click the link in the description. Thank you for watching. Together, we are shaping science.